So diffusion was defined as the movement of a solute from a high concentration to a low concentration until it reaches equilibrium. So in 6.2 of this lab, you're going to be looking at osmosis, which is basically the diffusion of water, the movement of water from a high concentration to a low concentration until water's concentration is equal. So that can also be looked at from the standpoint of the solute, right? So if the water concentration is high, that means the solute concentration is low, and vice versa. So you will also hear diffusion defined as the movement of water from a low solute concentration to a high solute concentration. So it is important that you read carefully as well as speak and or write carefully so that you are describing what is causing this movement. So in this experiment, you are creating 4 different environments. You're going to be using 4 different bags, which are going to mimic cells, right? So you're going to be using the same dialysis tubing that we talked about for 6.1, right? This dialysis tubing has pores in it that will allow some substances through, but not others. In this case, we're going to be using water and sugar. So the water is small enough to move through the bag, but the sugar is not. So the sugar is going to stay on either side of the bag and not influence this experiment. So we're setting up 4 different bags with those 3 different environments. So review your information about hypertonic, hypotonic, and isotonic. So hypertonic means that there's more solute than the area we're comparing it to. Hypotonic means there's less. So when we look at these 4 bags, right, you will notice we have 2 beakers, and in those 2 beakers, there's 1 in the first and 3 in a bigger beaker. That is because the 3 bags in here are all sitting in a 1% solution of sugar, as where the first one is actually sitting in a 25% sugar. So it's a dramatic difference there. So bag A is a 1% solution of sugar inside of the bag and a 25% outside of the bag. Then bags B, C, and D are all in that 1% sugar solution. Now bag D is the most dramatic here, right? It has a 25% solution of sugar inside of the bag and only 1% outside. 10% for bag C inside, and then again 1% on the outside. And then a 1% and 1% for bag B. So that means B should be what we would consider our isotonic solution because bag B has the same amount of sugar in it as there is outside of it. So we'll see what happens with this. Bag A is going to be hypertonic, right? I should say the solution outside of bag A is hypertonic. So because it has 25% sugar outside and only 1 inside. Bags C and D are both sitting in hypotonic solutions. They have less sugar outside than there is inside. So if we're comparing bags C and D, then we will see that D is more hypotonic. It has a greater concentration gradient than bag C. Bag C has a difference, but it's not as great as our bag D. So if we remember what we've learned about hypotonic and hypertonic, if something is in a hypertonic solution, then it should lose weight because the water is going to leave the bag, in this case, to try to equal out the concentration outside of the bag. Hypotonic is going to gain weight because the water is going to move from outside of the bag into the bag. So with this experiment, right, we had these 3 bags. And they all started at about 10 grams, give or take, because the 10 milliliters of solution that's inside of the bag is about 10 grams. And then you add in the bag and the tape and whatever else that's in here, and you see a pretty equal-ish weight. Bag D was a little bit higher than the other, even though I screwed up writing it down, wasn't fixing it. So let's look at what happened to this over time. So we started with an initial weight for bag A at 10.1 grams. And bag D was already a little bit heavier at 11.1 grams. But after 15 minutes, it's already obvious what happens with these solutions. All right, so at 15 minutes, bag A lost weight. Bag B gained a little bit of weight, so we'll have to watch that one because that's the one we're expecting to stay about the same. Bag C gained a little bit of weight, and bag D gained even more weight than bag C did in proportion. All right, so before I look at the rest of the data, one of the things I want to show you is what these bags actually look like. So let's get these out of the way. Bag A was sitting at 25%, right? So we were expecting, because it's sitting in a hypertonic solution, that it should lose weight. So I want you to even just look at what this bag looks like right now. Right, kind of floppy, right? It's not very firm. It's kind of lost all of its personality. All right, but then let's compare that to bag D. So bag D is big. It's firm. It's what we would call turgid if we were talking about a cell, especially a plant cell. All right, it is very firm and contains a lot of structure. So that helps to give us kind of some evidence, even more than just the weight numbers that we're going to look at. So at the end of the time that we looked at, bag D was very firm, right? Even looks like it's gained weight. Bag A is really floppy, like I can literally bend it in half, right? It has obviously lost weight. So if we look at the numbers, production value, you can see that over the course of the 1 hour, right, bag D continued to gain more and more weight. Bag A continued to lose more weight. Bag C did gain some weight, but not as much or as dramatically as bag D. Again, because remember, bag D, it has a higher concentration gradient to start with. And then bag B did equal out, right? So it did start at 10.3. It gained a little bit, but then it equalized, right? That equilibrium shows that this got to a isotonic solution or isotonic environment pretty quickly, right? Bag C and D gained weight because water was going from a higher concentration of water outside the bag to a lower concentration of water inside the bag, so that caused it to gain weight. Water moved. Now in bag A, we saw the opposite. Since it was in a hypertonic environment, the water left the bag to try to equalize the concentration on the outside of the bag. So what you can see here is that all of the bags did change weight a little bit. Basically what this helps to show you is that water is always moving. It's always trying to equal out the environment. Even in what we thought should be the isotonic environment, water still moved. Basically, water's always moving to try to equalize where it is. Therefore, all of the bags changed a little bit. And again, we saw it more dramatically where we had high concentration gradients, both in bag D and bag A.